First principle of derivative states that dy dx, which is the same as y prime, is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. That is the first principle of derivative. And the principle just states that if you have a function and you want to find its derivative, or the dy dx, which is also the y prime or f prime of x, then it's basically the limit of a function that is called f of x plus h minus f of x all over h as x approaches 0. And so whatever value or function you are going to get after finding the limit becomes the derivative of that function. So let's take an example. We have f of x to be equal to x squared, and we are asked to obtain from first principles the derivative of this function. Now, the question was very clear that we are to use first principle, and that is what first principle states. dy dx is equal to limit of f of x plus h minus f of x all over h as h approaches 0. So now, our f of x is x squared. We want to find f of x plus h. So now let's start solving. Step 1, f of x plus h. Now, what this means is that we are going to put x plus h into the function. Now, if you have f of x equals 3x, if you want to find f of 2, what do? You put 2 into f of x. So it's going to be 3 times 2. Now we have f of x to be x squared. Now you want to find f of x plus h. What do? We put f of x plus h into the function, right? So we are going to have x plus h all squared. We are just basically putting this in place of x. So x plus h becomes one variable which we are putting into x over here. And then we squared it, right? We can expand this, right? And this becomes x squared plus 2xh plus h squared. If you expand this, this is what you are going to obtain. Now we have f of x plus h, we have f of x. Now we can put in back to the first principle of derivative formula. So let me divide it. So we have dy dx equals limit as h approaches 0 of f of x plus h. We have f of x plus h as x squared plus 2xh plus h squared. Now we have minus f of x. Minus f of x is x squared. So we have x squared, then all divided by h. Now we have positive x squared here and we have negative x squared here. So this cancels this. So we have dy dx equals lim as h approaches 0 of 2x plus h squared all over h. Now we know from mathematics that this actually means dy dx equals lim as h approaches 0 of 2x each over h plus h squared over h. Now these cancel these out and is left with dy dx equals lim as h approaches 0 of the function 2x plus, now h squared divided by h is going to be h. So this is the function we are having now. Now you want to plug in 0 into the function. So h is 0 is going to be 2x plus 0, and that equals 2x. So now dy dx of the function x squared is equal to 2x. We have used the first principle to obtain the derivative. And so this is how it works. Let's take another example. We have to obtain from the first principle the derivative of y equals 5x. Now it states that dy dx equals lim as each approaches 0 of the function f of x plus h minus f of x all over h. So now, step 1, what is our f of x plus h? Now remember y equals 5x is the same as f of x, right? Now, so we have our f of x to be equal to what? 5x. Now what is f of x plus h? This is going to be 5 times x plus h, right? Just assume this is one variable and substitute into the function. So let's say this was e, it is going to be what? 5e, right? But then e is x plus h. So it's going to what? 5 times x plus h, right? That is it. So always assume it is a one variable and then substitute into the function given. So f of x plus h is going to be 5x plus 5h, right? Now we know f of x already. So now coming back to the formula, dy dx equals lim as h approaches 0 of f of x plus h, which is 5x plus 5h minus f of x, which is 5x all over h. This cancel this out, and this equals limit as h approaches 0 of 5h over 5, sorry, over h. So h cancel h out, and this equals limit as h approaches 0 of the value 5. Limit of a constant is equal to the constant. So dy dx equals 5. Let's look at another one. Y equals 8. We have to obtain the derivative using the first principle of derivative. So now we want f of x plus h, right? And this is going to be 8. Why? Now y equals 8 simply means y equals 8 x to the power 0. Now if we take this to be equal to f of x, then f of x plus h is going to be what? 8 times x plus h raised to the power 0. Now x plus h raised to the power 0 is 1, which becomes 8 times what? 1, and that equals 8. So f of x plus h in this case is 8. Now we know how f of x to be equal to 8. So now we can go ahead and calculate for dy dx, which equals limit as x approaches 0, h approaches 0, of the function f of x plus h, which is 8, minus f of x, which is 8, all over h. And then this becomes limit as h approaches 0, 8 minus 8 is 0 over h. Now, 0 divided by h is equal to 0, and limit of a constant 0 is equal to 0. So dy dx of this function is 0. Let's look at another complex one. F of s has been given as 2x to the power 3 plus 3. Now, let's find f of x plus h. This equals what? 2 times x plus h to the power 3 plus 3, right? Then you want to expand x plus h to the power 3 all times 2. And so if we do it well, you are going to obtain 2x cubed plus 6x h squared plus 6x squared h plus 2h cubed plus 3. When you expand this, you are going to have up to here and then plus 3. So that is what we have here. Now, we know f of x, and so we can then put it into the formula. So dy dx is limit as h approaches 0. F of x plus h is now 2x cubed plus 6x h squared plus 6x squared h plus 2h cubed plus 3. Now make sure you pause the video and then expand this yourself, and make sure you expand and then get what we have in here. Now, this minus entire f of x. So minus f of x is 2x cubed plus 3. So 2x cubed plus 3. So because of space, let me just apply the negative to each of the terms there. So minus 2x cubed minus 3. Then all over h. But I want to first eliminate some of the terms because of space. So this eliminates this. Then we have this cancelling out this. So I can now erase them. Let me erase this. Then let me erase this. Alright. So I can now divide it by h. Now 6x h squared divided by h is going to be left with 6x h. plus 6x squared each divided by h is going to be left with 6x squared. Then this is going to be left with 2h squared, right? So you are finding limits as h approaches 0 of this new function. Now when we put 0 to this term, we are going to have 0. 0 times 6x is going to be 0. Now we have 6x squared. Then when we put 0 here, it's going to be 0 times 2. And so that one also eliminates. So we are having 6x squared as the derivative of the function f of x equals 2x cubed plus 3. So you have two assignments. And the first one is that you are to obtain from the first principle the derivative with respect to x of the function f of x equals 3x plus 1 over x. And the answer is 3 minus 1 over x squared. So make sure you get it correct. And then another assignment for you is that you have to obtain from the first principle of derivative f of x equals root of x.